Now, functions are usually of two types. One is a user-defined function. Second one is a built-in function. So first one is built-in function. Second one is user-defined functions. So now what is a built-in function is nothing but the functions which are predefined by the Python people. So these are the predefined functions which are using by us as we like it. We are not going to do any definition over there. It is all the predefined functions by Python. Example, and the function. Then there is something called as a print. I'm not sure, Dave. Can you see this now? Because this is not my internet. Can you see the screen now? And can you hear my voice? I didn't do anything. Okay, now let's see this because there may be some fluctuations in the internet. So maybe because of that. Okay, so one is length and print and ID and pass. Pass is a function. Is that a function? It's a keyword. It's not a, the function will be always having the parenthesis. Remember that. Okay. Int, string, right? All this comes under the functions, guys. These all are the functions. Okay. These are the predefined functions. Now, definition is defined inside the function. Like when the function was built, when the Python was built, they defined this one. You are going to use it as you like. These are called as predefined functions or the built-in functions. Now, next one is user-defined functions. These are the functions which are defined by the user or the developer as per the project requirements. Defined by user or developer, I can say developer or programmer as per project requirement. So this comes under the category of user defined functions. Okay. Now this one we are going to look at, not this. This we have already used it. Right now, how to define a function? Now, these functions are nothing but a block of code which can be reused n number of times as per our requirement. But these block of code will be executed when you call them. Otherwise, they will not execute on their own. So, user-defined function will be having, the function will be having two parts. Two parts. One is what is what? One is function definition. Second one is function calling. Okay. Now, function definition is a place where you put down the business logic. And function calling is the one you are going to call this definition part whenever we want it as per our requirement. Okay. Now, where exactly this will be using is something like this. If there is a repeated code is there in your, okay. Now let's take it. This is my code, guys. In this, there is a repeated code is there. Now there is a repeated block of code is over here. Okay. Now there is a repeated block of code will be over here. okay, and here and here. Say that each block is consisting of maybe around 50 lines. Here it is 50 lines, here it is a 50 lines, here it is 50 lines, and here it is 50 lines. In total, this total code is maybe around like 800 lines. The code is like total 800 lines. The total program consists of. Out of this, there is a first block is there, which is having 50 lines. The same block is repeated over here. Same block is repeated. Same block is repeated. How many repeated codes are there? Repeated lines. How many lines? 200. 200 is the repeated lines of the code is there. 200 repeated lines of the code. So here, when I'm using the repeated lines of the code, I'm wasting my resource. What I mean by resource is my developers. Developers are the resources. So I'm making my developer to write the same code here, same code here, same code here, and same code here. How many times? 4 different times, 4 to 10 times it can be. So I'm wasting my developer time. Right? Now, when I compile it, compile means compiler, right? There will be a compiler which will go and check the error, or compile or interpreter. It will go to the each and every line and it will check it out whether that code is correct or not. Here, total 800 lines are there. No problem. It will go to the 800 lines. But the problem is here we are having repeated 200 lines are there. So I'm making my interpreter to go to each and every line, even though it is a repeated one, and I'm making it to check it out whether there is an error or not. In this case, I'm wasting my interpreter time. Even though it looks very small in our small programs, it looks very small, but when we build up an application, right, it will be a very delay will be there. A lot of delay will be there. Sometimes, you know, I experienced, we built an application which is called as ROC, This was application which was built and this was taking nearly around, like, I was not involved, someone else was built up, and this was taking to run it, to completely run, that's a very big program. It was taking 10 minutes plus to run a program. Try to understand that it is taking 10 minutes plus time. And when I was allocated to that, we did a small changes. That's it, small changes, very small changes, like, you know, using the OOPS concepts and using the reusability, using the modularization. So we examined and we did a small changes over there, very small changes, guys. Maybe like I must have used maybe around, total code is maybe around 10,000 lines plus it was. I was used only 500 lines changes. I did it. That's it. And after doing that changes, this was executed within 35 seconds. See the difference. So that is what exactly happens. Suppose if you are going and opening an Amazon site, it is taking 10 minutes to open it. Now you will be getting frustrated, right? So now there is a small software company, another shopping site is there. That site is opening in 35 seconds. By the time Amazon opens, you will finish your shopping also with the other site, 10 minutes. Right? That is the difference. That is the major difference. So to make the customer happy, you have to make it an effective way of writing the code. Here, this is, you are wasting your time. You are wasting your time, your interpreter time over here. So your interpreter is wasted. Interpreter time is wasted. Now, these two are my valuable resources. They are my valuable resources. So I'm wasting my valuable resource time. And next one is the enhancement is difficult. What is this? I've done a mistake. Enhancement is difficult over here, or not difficult, it is difficult. Now, what do you mean by enhancement, guys? adding some new features to the existing code is called as enhancement. So enhancement is difficult. Why? Means that if there is a 4 blocks are there here, 4 blocks. If I want to add a new feature in this block, how many times I have to do it? 4 times. Suppose if there is a mistake is there in this, then how many places I have to go and change it? 4 places. So debugging and enhancement both are difficult. Debugging means removing the error. Debugging, bug means error. Debugging means removing of the error. Now enhancement means changing of the code. So when we are changing of the code, it is very difficult, and debugging is also difficult, guys. When you are going with this one. So to avoid this, what we are going to do it is the same thing. We are going to enhance, we are going to change the structure of this. We are going to have the same 800 lines of the code. We are going to have this. Okay. And here I am going to keep it. Only one block I will be having. Repeated lines, only one block I will have it. I will give a name to this one. Maybe I will give it as ABC function. And this one is a name of the function, and this is the definition block. That's what I said it. We will be having 2 parts. One is a function definition and function calling. Function definition is nothing but where we are going to put on our business logic. So here is a block of code where I'm writing my business logic, and this one I'm going to call it wherever I want it. Like this. Wherever I want it, I can call it. This is the definition. This is the calling of the function. Now, this one is very much similar to that of this one. Can you see this? This one, ABC of, this is calling part. This is definition part. So this one is very much similar to this one, right? Can you see it? This is the calling of the predefined function. Where is the definition then in this? It is there inside the Python. Inside the Python it is there. So you are calling it, you are using it. This is already predefined. But in this case, we are defining our own function definition, and also we are calling the function. So these are the 2 major parts. Okay. Let's see the syntax of the definition, guys. Now with this, what is the advantages? First thing is you will write the code how many times? Only once. How many times you are going to use it? N number of times. Okay. Now my resources are saved. Okay. My resources are saved. Now enhancement, if I want to do it, how many places I have to do it? Only one. Debugging, only one. It's very easy. Very simple. Now this is what is called as, the function, guys. Okay, now let me take this one. This is what I will say it as a function. Okay. Now you should understand this is the definition and this is a calling part. There is a special syntax will be there for the definition. How we should always start with DEF, and you should give the function name over here, function name, and ended with colon. What this colon says? Block of statements. Under this statement, there are a set of statements. A block of statement is there. That is what you are intimating to your interpreter, guys. Okay. Now, under this, there will be some statement 1, statement 2, statement 3, like this you will be having it. Okay. This is the definition block. This is the definition block. Now, this one is, what is this? Calling. Okay. How you will call? Whatever the name you are given over here. Okay, I forgot it. I have to have the parenthesis over here. Now, the same, how you give it over here, the same thing you have to do it over here. Calling is like this. Use the name and call. Okay, parenthesis. Okay, guys, clear? Now, this part is again has the 2 parts. What is this? What is this actually? Function definition. So function definition will have the 2 parts. One is called as function declaration. Okay. Declaration and function implementation. This I missed it for the other people. Now, what is the declaration over here? Under the function definition, there will be a function declaration and function implementation. What is the function declaration over here? The first line, whatever is there, this is the function declaration. Okay. Now, the whatever you are writing, the statements which are under the function, that one is called as function implementation. Okay. There is one more term is also comes over here, that is called as function signature. Signature. Any idea? Sir. Function signature is not declaration. How many types of arguments you are passing, that is called as signature. So you can also say that function declaration is also a signature, but usually how many arguments we are going to pass it, that is called as a signature. Okay, that is specially signature. See, हर एक के लिए it will be same. कुछ different रहेगा क्या? कुछ भी difference नहीं रहेगा. हर एक के लिए there will be DEF function, DEF keyword, function name, parenthesis and colon. That is common for all. That is called as declaration of the function. But there will be a variation in the arguments. Some may take one argument, some may take two arguments, some may take three arguments. That is, what is called as a signature. Okay, function signature is nothing but number of arguments. This is the first line of the function. Function definition. That is this part. I'm going to write it over here. Function implementation is block of code under the function declaration. Okay. Now, what is the signature? Number of arguments. Now, guys, I'm saying it is number of arguments in function definition, not inside the function. Not inside the function. At the function definition, the number of arguments is called as signature, not the inside the function. Don't get confused over there. Okay. Now, this is what is, guys. Now, again, the function calling is nothing but calling the function. Okay. Now, you have to know few points over here. Function definition will consist of block of statements, right? Block of statements it will be consisting of. So, under the block, you should have, there will be definition and the implementation and signature over there. Now, this function definition can exist without calling the function definition. Inside the program, you can keep the function definition, but without calling, it will exist. So before that, when the function definition will be executed, when you call it explicitly only, the function definition will execute. Otherwise, it will not execute. Remember this, the block of statements over here, whatever the block of statements are there, this block will be executed only and only if you call it. If you don't call it, it will not get executed. First point. And if a function definition can exist inside the program without calling, if you are having a function definition and you're not calling that, it will not be a problem at all. Okay, remember that. And function definition should be always before calling of the function. Function definition should be always before calling of the function. After calling of the function, if you are going to keep it, it will not work it out. Okay, guys. So first point is the function definition block. The definition block will execute when you call it. That's it. Otherwise, it will not get executed. Okay. Call it. Okay, the first point. Second, the function definition should be before calling of the function. Next one. और एक क्या बोला था? Execute. Can be or can exist. I should write it. Can exist without calling. It's not. It will not trigger an error. But when it comes to the calling part, guys, see, in order to call a function, before calling, the function definition should be defined. Definitely. So the function definition should be there in order to call a function. Function. Okay. And okay, you can call n number of times, and without definition, you can't call a function. Can't call a function. Now this triggers an error, guys. Remember this. In the first case, it's not an error. This one, I will say that not error. No error. Okay. Now this one is an error. Remember this. Okay. Now this is quickly about the function. Now let's go and implement the functions. Now before doing that, I want to say you something like modularization. You want to write it? Okay. Now here, when you look at this definition, guys, this definition is maybe around maybe 100 lines of the code is there inside this. This 100 lines of the code, I'm calling it over here 1 time, 2 times, and 3 times. How many times I called it? Total 3 times I'm calling this 100 lines of the code, right? How many times I wrote it? Only once. How many times I'm calling? Multiple times I'm calling it, right? I'm calling it multiple times. So this block of the code is reusable within the same program only. So this can be called within the same program. Okay, from outside also you can call it, but it doesn't make any sense. Okay, it doesn't make any sense. You can call, it is strongly recommended not to call from the outside because it will be executing multiple times. So this is a block of the code which is specially reused in the same program. But that is not the actual definition of the reusability. Reusability definition is write it once and use it n number of times by different people. That is the actual definition of the reusability, effective way of doing the reusability. That means if I am working in a team of maybe around 5 members, I am working it over here like this. This is my team of 3 members. A, B, and C. These are the 3 people are there. This is my team members. And I wrote the code over here like this. I wrote the code. This is me. I wrote the code. Now who can now say that this is a code which should be used by A, B, and C. Now this may be like connectivity to the cloud environment. There's a cloud environment will be there. The connectivity to the cloud environment, I wrote the code. This code is maybe around like all the configuration I did it, and this may be around like 100 lines of the code I wrote it. Now, this is specially used to connect to the cloud. I dump the data. I can use it n number of times in this my program. But this person can't use this. And this person can't use this. This person can't use it. Either what they have to do, they have to copy the code and put there in the program. Okay, and here also copy it and put there. That is again, you're putting an extra load in your system. That is not recommended at all. So what I can do it is, what I will, instead of putting this code inside my program, I will take a separate program over here, a common program, and whatever the code is there over here, this code I'm going to special effects. Okay. Now this code, I'm going to put it over here, guys. This code. Now there won't be any code over here. This code will not be there. Now, when I want to, I put it in a separate program called as MOD. MOD is a program I used it. I wrote only the definition part. See this, only definition part. And I'm calling it over here. Where is the definition? In this mod.py. Okay, where I'm calling? In my program over here. But there is no relationship between. Now, if I'm executing it over here, this will trigger an error. Okay, so what I have to do it? I have to establish the relationship between these two. That is nothing but import mod, right? And this one I will do it mod.py, that mod.abc. That's what I will do it. Now from here it will go and it will execute the code over here. Now what is the advantage of this one is that A can use it, B can use it, and C can also use it. Okay, now this way of writing the code in the modules is also called as modularization, they will call it, and otherwise it is also called as building up of the framework. So usually, you know, when the senior people, like maybe around 7 to 8, 10 years people, what they will do is they will develop a, you know, predefined, project specific framework. They will have the complete sketch, what code we have to reuse it, where we have to put it, who will be doing that, everything will be taken care in a proper structure, in the folder structure. This folder structure is called as a framework, guys. Now there is some more like built-in frameworks are there with the Python. What are those? There are some frameworks, very popular frameworks are there with the Python. Django is a framework. So when you install the Django and when you start a project in the Django, already you will get folder structure. You don't need to do anything. By simple doing the Django, you will get the framework over there. Automatically you will get, that is the actual framework. That is, you will get all the predefined steps, whatever is required, you will be defined over there automatically. I will show you if you want it. I don't know if I have the Django or not. So that is the way it will come down. Okay, that is a framework. Framework means predefined steps with the logic on. This usually every project will have the framework, and this framework, how it works, which folder, what is there, that will be documented. Once you get into a project, they will be giving you this document and ask you to go through the complete documentation where you will be seeing the structure of the framework, how it is going on. Okay. So that is what is called as a framework, guys. So I will show you the Django framework, not a problem. So this is called as a modularization. So this can be implemented effectively when you use the functions. Okay, and you can use it with the classes also. That is even more beautiful. That is even more very secure. You can use it with the class object also. I don't know, like if you people are done the oops. Question mark face. You never done the oops. कहीं सुना लग रहा है ना? ऐसे ही होता है. Oops. Done. Have you done the modularization of the oops? Ante and adagaku. So that is even more effective, guys. Done. That's great, Balender. Thanks for confirming me. Okay. So that is wait. The oops means oops is very, very effectively using with the modularization. Now see this. If I'm having the main logic is over here, just think that my main logic is over here. Now I am executing from here. From here, it will go and execute over here, right? Now, if someone wanted to steal my code, there will be a lot of people will be trying to hack into your system and want to steal. They will come to this system. What they will get? They will not get anything. Where is the logic? Logic is over here. Then again, they have to go and find out where is this mod, and they have to crack that one. Then only they will get it. Okay, that is a problem over there. So again, if I will connect it to the different modules, then they are lost. They can't get it at all. Okay, that is the advantage of modularization. So you will have an perfect reusability along with security. That's what I said it over here. Where is that? Here. When you use the function with modular, then it is a perfect reusability plus security. Okay, this is what now usually when you want to build an application. Now if you are putting some real-time experience in your this thing and you are going for an interview, then they will definitely ask you this question. That if you are putting some experience and wanted to go and attend an interview, they will ask you how you implemented the project, what is the modules. Okay, now quickly see this one, guys. Now you understood what is a module, you understood what is a function, function definition, declaration, implementation, everything. I don't know, like now like function, I will write it function one. Oh, what is this? I created a package. Now guys, let's have a definition. DEF fun1. Okay, now this one I'm having two arguments I'm going to take. I will take the 3 marks from the student. So English marks, int of input of enter English. Now science, int of input of science over here. Science. And then I will take the computers is equals to int of input of computer. Okay, this is the definition part. I want to add them. Guys. Total is equals to English plus science plus computers. Now I will get the average total by 3, right? Now print total and print average. Okay, now this is my complete business logic. Okay, now this one I have to call it. How I will call it? Just use this one, right? Now if you run this one, you're going to get it. I will say that 60, 70 and 50. Okay, when I do this, I will get it like 180. Clear? Now this is like, now I don't want to take the values from here. I want to pass the values from here, from the calling part. Let's do the modularization. Mod 1. Okay. Now, this is the output. This is my business logic. This is my code, right? From here, I'm taking this and I'm putting in the mod. I said that mod should never have the execution. This calling part, it should not have it. Okay. Now, where I'm calling, here I'm calling. So how I'll call it? import mod 1, one mod kaadu, mod 1. Okay, then mod 1. Clear? Now if I do this, automatically it will run it. Okay guys, clear? Now see this, I don't want it to take the values from here only. I want to take the values from this one here in the main program. Can I do this? This is my main program. This is my main program. I'm taking the values over here. But how to do the addition over here then? I have to pass the values from here to here, right? To pass the values, I will pass it on English, science, and computers. Okay, but when I'm passing the values, that has to be accepted over here. I will be writing E, science, and computers, and here I'm going to use it. Okay guys, see, I'm taking the value over here. This is my main program. I'm passing on the values to this, and I'm printing the output over here. Now I want to print the even the marks also, means you can print the E, print E, print S, print C. Okay, I took the marks over here. I passed on the marks from here to here, and here I'm calculating the total and I'm printing them over here. Clear? Now let me run this one. Now what's the problem? Sorry, here I call the function. I executed this one. I didn't execute this one. Here you see mod 1 I executed. Here I will give it 50, 50, and 50. Now this one is from my main program, guys. From here, the cursor will be going on to, from here, I took the 3 values, okay? And then I'm passing on those 3 values to the function 1. Where is function 1? Inside the mod 1. From here, it will call this one, put the English in this, put the science in S, and computers in C. Now it will do the addition, it will do the total, and it will print the output over here. Clear? Now this is what it will go on. Now I will run this one. You see, you will getting the output. Clear, guys? Now this is a normal way of doing the program. Now let's do it with the some more arguments, different types of arguments I'm going to show you. Now here is my business logic. I'm taking the business logic. Now here I'm taking the values, guys, over here. I'm taking the values, or let's take a small, take the definition of the function over here. def add, okay, it will take it as n1, n2, and n3. Okay, n1, n2, and n3, and I'm doing the addition. A is equals to n1 plus n2 plus n3. Okay, I'm going to print it A over here. Now where I have to get these values, I have to pass it on while calling it, right? How I will call it? Add of 100, 200, 300, like this. So now when I run this one, you will be getting an 600. So 100 is going into N1, 200 is getting into N2, 300 is getting into N3. Now on what basis it is doing? Based on the position. So these type of argument, when the value is assigned to a argument means this is the one, guys. When a variable is defined at the signature part is called as an argument. Now what is this? This is a variable inside the function. This is a variable, and this is a local variable. Okay. Now, if I run this one, I'm getting it like 100 is getting into N1, 200 is getting into N2, 300 is getting into N3. Now, this way is called as positional arguments. So there will be like around 5 types, right? 5 types of arguments are there. First one is called as positional argument. Second one is keyword argument. Third one is default argument. Fourth one, variable length argument. And keyword variable length argument. And variable length argument is represented by star AR. ARGS is the word. You have to use the star ARGS. Okay. And keyword variable length argument will be represented by. Okay. Now, this is the positional argument. This is the highly prioritized one. Positional argument is the highly prioritized one. So then what is called as keyword argument? Whenever an argument is initialized at the calling point is called as a keyword argument. Now, this is the arguments, right? I'm initializing them at the calling place. This is a calling of the function. I'm initializing an argument at the calling place. Now, you see this N1, N2 or N1 over here, N2 over here. Now, N3 is over here. Now, when I initialize something like this, I'm initializing a value to the arguments at the calling place is called as keyword arguments. Now, you may ask me, what is the difference? The advantage of the keyword arguments is positional arguments is based on position, the values will be assigned. But in this case, you can shuffle the value. I can put it as N3, this one as N1, and this one as N2. Now, if you print it all the three, print N1, N2 and N3. Now, if I run this one, can you see it? N1 is 200, N2 is 300, and N1 is 100 over here. 200 over, we got it. Sorry, I missed it out. N1 is 200. N2 is 300 and N3 is 100 over here. We shuffled it. Okay, we can do it as we like it. Now, this is the advantage of the, keyword variable length argument. Again, guys, keyword variable length always should follow, not keyword variable length. It is a keyword argument. This keyword argument should be always follow. I'm saying it should be after positional argument. What I mean is, now if I'm doing like this, okay, now 100 is going into which one? N1, right? On what basis? Position basis. Now N3 is 200, I'm giving it. N3 is 200 and N2 is 300, right? Now if I run it, it will run, no problem. N1 is assigned the value based on the position. N3 is assigned based on the keyword. N2 is also assigned based on the keyword, right? Now, what I will do it over here is, see, always this should be the hierarchy. First, there should be a positional argument. If you want to keep up a positional argument, this should be the positional argument followed by keyword arguments. Okay, keyword arguments. So here, if I do it something like this, N3 is equals to two, and here I will give it, sorry, N1 here, I will N2, I will give it, here I will give it as N1, and here I will give it 300. Now what I wanted is something like this. This one 100 should go into N2, right? 200 should get into N1. This one should enter into N3, right? It looks perfect. These two are based on what arguments? They are called as keyword arguments. What is this one is? Positional argument. Now, as I told you, the positional argument should be always in the before the keyword argument. It should never follow. That will be the error. You will be getting it over here. Can you see this? Positional argument follows the keyword argument. That is the error. You should never follow it. So this should be always at the starting. Or give it something like this. Then it is not a problem. All the three are keyword arguments. Okay, guys. Now this is what is a. Now if there is an, I want to pass on only two values over here. Two values, 100 and 200. And 100 will be getting into N1. 200 will be getting into N2 and N3 no. So what will happen? Error will be coming down. Okay. Now you see add function missing one required positional argument. So in this case, what I may give it two arguments also. I wanted the three arguments. What is expecting two values? I will pass it on. Then this should execute. Then what I can do it, I can make it one of them as a default argument. When I make it as a default argument, if I'm passing two values, 100 will be getting into N1, 200 will be getting into N2, and N3 is 0. Right? Now you see this, you will be getting N3 is equals to 0 and you will be doing the addition. Now, if I want to pass on the 300 over here, then this one will be given preference. So N1 will be having 100, N2 will be having 200, and N3 will be having. Okay, guys, this is the positional or the default argument. Now, what is the variable length argument is? The variable length argument is three. Yes, 3. See, when a function is there like this, okay, this is my function. And how many arguments it is accepting? 3 arguments. How many values I have to pass it on? 3 values, right? A is equals to N1 plus N2 plus N3, right? I will print it A. Print it A. Now here, I will do it like add. I will pass it 100, 200, 300. Now, like this, if you are having a lot of values are there, the positional argument values like this we are having. So many variables I have to give it. I don't want to give it so many variables. That will be a problem over here. How many values I am passing, the same number of arguments should be there over here. Otherwise, it will give us an error. To avoid this complexity, what I can do it is, I can use it star N1 or something like that. Now, you can give it any name. So star N1, what happens when I'm giving star N1 over here is this becomes a special variable. And this is having the power to accept n number of positional values. Now, positional variable values will be there, right? Positional argument values will be automatically getting into this and it will be stored in the form of tuple. It will be stored in the form of tuple. Now you see this, all of them are accepted. Now, if you want to add them, how to add them? S is equals to 0 for I in N1. S is equals to S plus I. Print S. That's it. Because this is a tuple, guys. We can extract the values from the tuple by using for loop. Now you see this, you are going to get the output over here. Now, because of this one, the Python will not support the function overloading. There's a concept called as function overloading. You know it? Huh? Balendra, you know it? What is function overloading, Balendra? Okay, I got it. You know it. Yeah, that's perfect. Same different arguments, right? So that is a perfect one what you said it. So if a function is there and function name is same and signature is different, signature means argument, when the signature is different, then that is called as, you know, overloading. That is not supported by the Python. No way, we will not support it, because we are having a much more better mechanism called as variable length argument. Using the variable length argument, you can come up all the function overloading. That is not the function overloading, it is called as method overloading. The function inside the class is called as a method. So the concept is called as method overloading. So method overloading or the construction overloading is not there in the Python. Okay, not the complete overloading. Only function overloading or method overloading, and the construction overloading is not there. What about the other overloading, guys? Variable overloading and operator overloading is also there. That you can perform it, no problem about that. But usually, you know, most of the people, whenever they talk about the overloading, they will be in a misconception that it is the method overloading only. But that is not the case. Method overloading is one of the mechanism, one of the way of proving the overloading mechanism. So there are like method overloading, constructor overloading, variable overloading, and operator overloading. So first two we are not able to do it. The next two you can do it with the function guy, sorry, Python, with the Python. Why we are not able to do it means is that the overloading is not so important, means it's very, very important. Very important, but Python will not support because of this one. What is this? Variable length argument. Okay, now if I'm having a keyword argument over here, a is equals to something like this. Now these all the positional values, right? Positional variable values. This can be accepted n number of them, but when it comes to the keyword argument, it is not accepted. C is equals to, these are not accepted inside this. To hold the multiple keyword arguments, we are having a keyword variable length argument, and two you can do it. Now keyword variable length argument accepts n number of keyword arguments and stores in the form of dictionary. Now see this, I'm just commenting this, we don't need this. I will run this. You see this, A is a key 300, B is the key 200, C is a key 300 again. So something like this it will be happening, guys. So again, these, there is a specific naming convention is there. Whenever you are using the variable length argument, use the ARGS, and whenever there is a keyword variable length argument, use the KWARGS. This is mandatory, remember that. Okay, it's a coding standards. Now if you are accepting the values, you use the star ARGS while printing ARGS, and while printing no need of using that, just print it as a normal variable. This one I will use it KWARGS. Okay, clear, guys? Any questions? Now we can, there is next concept is return statement. See, as we passed on the values into the function, just see this, I'm having a function fun1, I will say that std, I'm passing three values, n1, n2 and n3. These are our English, science and computers. 3 marks I'm passing. So while calling, I will pass it. I will calculate the total. Total is equals to E plus S plus C, right? And average is total divided by 3. Good, clear? See, ARGS and KWARGS is a naming conventions, Amitabh. It is like whenever you are using a variable length argument, right? Please use the variable name as ARGS. Okay, whenever you are using a variable length argument, use it ARGS. This is the naming convention. Okay, naming convention here. So why it is we have to do it is because if you wanted to, if you are writing this one ARGS, it is automatically, it is understood that this is a variable length argument. If there is a keyword variable length argument, use it KWARGS. This is also called as coding standards, naming convention or coding standards, guys. Convention or coding standards, like this you will be doing it. So this is up to you, like how you want to do it. If you don't want to give it KWARGS and you want to give it your name is, you can do it like you can give it A, or you can do the K over here. No problem about that. This is not a problem at all. But the people will strongly, the Python people strongly recommend to use it AWARGS and something like that. Like this, they wanted you to do it. Okay, clear? Amitabh. Okay. Now let's take it STD. I'm passing on the three values, guys. STD is equals to like 50 is the first mark, 60 and 80. I gave it 80. Now I'm getting the total, I'm printing the total over here, and average, no problem about that, and average. Now this is a normal way we will do it, and you will get the output over here very comfortably. We will get the output, but I don't want to print it this one over here. I want to get it to the down over here to the main program, and then I want to print it. Okay, guys, then how you will do it? You will be passing, or you will be using the return keyword over here. Return total and average. So the return is a keyword which returns a value, whatever the value you wanted, that will be returned to the main program. So where you will be catching that one? Here. Wherever you are calling, you will be catching over there. Here I will catch it in A and B, because this is again on the basis of position you are going to get it. Total will be coming into A and average will be coming into B. Now how it will be going on is, it will come down over here. There will be a function, a calling. It will enter into this. It will do all the necessary things, and it will return the value to the place wherever you want it. Now if you want to print it, means you can just print it over here. Print A and print B, something like this. Print A and print B. Okay, guys. Now I want to calculate the average over here. How to calculate the average? Sorry, not the average, grade. If B is greater than or equal to 80, what will be there? A. If B is greater than or equal to 80, then it is B. What I'm giving is BA. Else I will give it as again one more if condition. If B is greater than or equal to, then I will give it as B over here. Else C. I'm making it very small. Now you can do it. You know it very well how to do it. Now this will give me an output. I'm printing it directly. Okay, guys. Now let me see this, whether I'm going to get it or not. I'll get it B. Got it? Very comfortable. So the advantage of the return is, first thing is, it can return n number of values. N number of values. No problem about that. Okay. Now n number of values, when you are returning, the same number of variables you have to mention it to accept those values. Okay. Same number of variables. Here 2 means 2. 3 means 3. 4 means 4. Either the number of values, whatever you are returning, it should be having the same number of variables, or you can have it only one variable. Anything you can keep it. If I'm passing on, like here we are having ESC, I'm passing on ESC, comma, how many values I'm passing on? 5 values. How many variables I should have it? 5. Or you can keep it 1. Don't keep it in the middle. Either it should be same or 1. If it is same, you are going to get the same number. We have seen it like. Okay. Now, if I'm keeping only 1, all the things will be entering into this one only. Now you see this. Now this one will not make any sense. Now you see all of them, we got it in the form of tuple. Okay. Just you can play with the things like this. Remember this one, guys. The return can return n number of values, and you know, if you want to catch those n number of values, keep the same number of variables, or what you can do it is you can keep it only one variable. Okay, and you will be receiving all the values in the form of tuple. Remember this format. Remember. Okay. Now when you are doing unpacking, you will get at a list. This is the case. Most of the time you will be getting in the tuple only. Okay, and one more important point is try to keep the return keyword at the last. This should be the last statement of the function. Never keep it in the middle. This should be the last, because this will be throwing the cursor out of this function into the main program. Then you will not get it. Okay, guys. Now, any questions? You have it over here. इसमें बात करो, आ जाएगा सब कुछ. दो वेरिएबल में क्यों स्टोर करे? उसमें से निकालो ना ग्रेड. एवरेज कैसे निकालोगे? कौन सा पोजीशन पे एवरेज है? वहां पर देखो, लास्ट वाला क्या होता है? -1 होता है ना. -1 लगा के कर लो ना. क्यों निकालना चाहते हो? फिर निकाल सकते हो, कोई दिक्कत नहीं. But you do it in that way. Now you can use it the star over here. I don't know whether it will work or not. काम कर रहा है. Now I will give it as over here. Now it will work. ठीक है? Now guys, next one is like 3 important concepts. What is that? Nested closure property, nested function, and reference. Function reference is stored in a variable. Function reference is stored in a variable. Huh? Function reference is stored in a variable. Variable length argument is represented by the variable name. Variable length argument is stored in the variable by the name ARGS, right? That is the coding standards. Okay, naming convention, like it's up to you. Like if you want to store and keyword arguments in a multiple keyword arguments in a variable in a single variable, what is that variable? What is the name? Keyword variable length argument. How you will represent that one? $KWARGS. KWARGS is a default format. If you want to give it, or you can go with whatever you want it. But remember that. Okay. In the same way, whenever a variable is holding the function reference, that variable name is func. Okay. Func. Now we are going to look into the variable reference, guys. Sorry, function reference. DEF, I have a function called as like ABC. ABC. Now this function has to print a table. Okay, just take it as this function has to print a table. I'm taking the number n1 and I want to print a table for I in range of 1 to 11, right? And print the table. Table will consist of, correct, Balendra. Now here I will give it as n1 comma star and I is equals to num1 into I. Clear? Can I execute this one? No results. ABC, I'm calling this one. Okay. Now I'm calling this one and I'm passing the value 5. What will be the output, guys? Okay. Fine. Now this is a function, a structure, and this structure is stored in a place. Definitely it is stored in a place. This address is stored in a variable called as ABC. ABC is the function name. This is the variable. This is the variable as the same name as that of function. Okay, same name as that of function. So if you pass it on, like if I'm saying it like this, what is this? This is the function call, right? I'm calling the function. This function I'm calling, and okay, let me remove this one. Okay, I will put it on 5 directly over here. 5 and 5 over here. I'm printing the 5 table or 9 table. We will do it. Okay. Now this is the function calling. This is the function definition. But how usually people will not think this one. They will blindly believe that because this is a function name, okay, I will call it the same way. But actually it's not like that. Internally, now when I run this one, you see this, internally what happens is whenever a function definition is being created, automatically the interpreter or the PVM will create a variable of the same name and store the address of this function inside this variable. It will store the address of the variable, this function inside this variable. Okay. Now, whoever is holding the address, they are the authorized person to call the function. That is a basic property you have to remember. Whoever is holding the address, they are the authorized person to call it. Who is holding the address now? ABC is holding. Is this holding? Yes, it is holding. Just I will print it. See this? When I do this, I will be getting it. Address of the function ABC. This is the function. Now, when I am saying off, what will be the output? Think over it again and say it. Huh? Sorry? वो निकाल के बात करो ना, समझ में नहीं आ रहा है. Just only table. वो कोई भी बता देगा, वो टेबल आ जाएगा बोल के. What will be the output, guys? Huh? Table, you will get it. There's something else, you will get it. None. Why are you getting none? Why are you getting none? Yes? Someone said it. Huh? Values are dumped. No. By default, I got an online. Yeah. Can you see it? What is that? Correct, Balendra. See, this is returning, always a function will return a value. If you are returning explicitly or if you are not returning explicitly, always function will return a value. That value is none. If I'm returning anything like this over here, return 10, then I'm going to get the 10. If I'm not returning over here, then by default it will return none over there. So that value is coming down over here and I'm printing it directly. Okay, I'm printing it directly. Of course, this is calling the function. This is calling the function. No doubt this is calling the function. Clear? Now this is calling the function. Okay. Now if I am giving a is like x is equals to, now what will be the x value? X value? ABC. Have you got the ABC? What is ABC first of all? What is the x value I'm asking? None. Because what I'm doing it, this is returning a value. Default return value is none. So this value will be returned. That is done automatically. That will be coming into x. And if you print it x, then what you are going to get it? You will get the none over here. Can you see it? You will get the none. But remember this, if I am returning over here 100, guys, what is the value of x? 100. If I am returning over here like apple, what is the value of x? Apple. Remember this, you will be getting the apple over here. If I am not returning anything, none. Clear? Now this is what function calling. This is called, it enter into the function and by default it is returning a value and it is stored in the x and that is printed as none. Okay. Now if I'm giving it like this, what is ABC? ABC is what? Reference, a variable which is holding the reference of the function. Now this is ABC is a variable which is holding a value called as reference of the address of the function. That is a value. That one is assigned to which one? X. Now what is the value of x? Address of the function. Address of the function. Now you see this? Clear? It's as simple as that, like I told you, y is equals to 200. Z is equals to y. Now, sorry, y. And if I print Z, what are you going to get it? What I'm going to get? Z, 200. That is what? This is holding a value. What is that value? That value is the address of this one. Now I'm passing that value to which one? X. Now X is holding the value over here. Now that value, whatever the value is there, that is passed on to X and X is holding the value. What is that value? Is the address. Now you see this? That value will be there over here. Clear, guys? Okay. Now, as I told you, the fundamental property is whoever holds the address, they are authorized to call the function, right? Whoever holds the address, they are authorized to call the function. Now, who is holding the address? Who all are holding the address over here? Only X. ABC is also holding the address. I will print the ABC over here. Just see. Okay. Now, let's see that whether both the values are same. You see, both the values are same. So, if I am doing it ABC off, then what is that I am doing? Calling the function. Now, if I am doing X off, what I am doing it? Calling the same function. No problem, because both are having the address. So, I am calling it. Now, I will print it over here. Now, when I run this one, I am going to get it this one. Clear, guys? Now, this is called as function reference. Okay, function reference concept. Now, if you want to pass on this reference to the another function also, you can do it. Now, if suppose if I am having another function over here, def sky function. Sky function will accept a variable value. I will give it as v. Okay, I am printing this is from the sky function. And I will print the v and I will print the type of v. Now see this, just ignore this part as of now. Now how many functions we have? 2 functions. Now I want to call the sky function. How I'll call it? Sky of value. You pass it on the value. One value we will pass it on. You will get the output, right? What value I passed on? 100. The same value is passed on inside this and it is printed. Okay, clear? If I am passing on a list over here, okay, what will be the value inside? List. And what is the type? Class list. See? Clear, guys? Okay. Now you will be getting it over here. Now, if I pass on here, just see this, x is equals to ABC. ABC is what? Reference of, right? Now that reference is passed on to x, right? Now I'm passing on the x over here. Can I do this? What is the x consists of? Reference of this function. Now this value will be caught where? Inside v. Now v is what? Function reference. Now using the v, can I call this function? Yes, you can call. Whoever is holding the address, they can call it. Now how many variables are holding the value of the function reference now? How many variables are holding the function reference of ABC? Huh? कितना हुआ? 4 हुआ ना? 5 हुआ? 3. Okay. First one is ABC. Second one is X. And from the X, I'm passing on to V. How many total? 3. Now using the 3, I can call. Yes, you can call using the 3. Now here I'm not calling now. I'm not calling the function at all. Just I want to show you the value. This is from the sky. Okay. Now here you observe it, guys. This is the ABC function reference. Can you see it? This is the ABC function reference. Where it is? This is from the sky function I'm printing. Which variable is holding this? V. And what is the type? Class function. Okay. Now can I do this way? Can I do this way? What is the V? V is having what? Function ABC. Now whoever is holding the reference, they are authorized to call the function. Now V is having the address. I'm saying V of, can I call this function? Yes, you can call it. Now see this. Got it, guys? This is the concept of passing on the function, one function reference to the another function, and you can use that. Okay, now this is very effective while you're doing the modularization, because different programs are there. Now in this case, I can directly call it like this also. While you are doing all these things, I can call ABC, right? You can do it like this also, no problem. But you know, just to understand that we can pass on the reference of the one function into the another function, I'm showing it. This is the concept of function reference. Okay, guys? And okay, one more important point, I forgot it. See, here, this is what? This is a variable, right? Variable argument. What is holding? This will hold a value. When that value is the function reference, always use func. Now this is the coding standards. Just like ARGS, AWARGS you are using, func is the one you have to use it, which comes into the category of coding standards. This says that this is a variable which is holding the reference of the another function. Okay, reference of the another function. A function which is holding the, which is accepting the another function reference as an argument, that function is called as higher order function. Remember that, higher order function. This is an higher order, yes. Any function which is accepting another function reference as an argument, that is called as higher order function. Okay guys, now you can use it over here, func. Now that is the reason why whenever you see the decorator, you will be seeing the first outer function will be having func over there. Func. That is means it is holds the reference of the main function. Now you see. Now let's do it with a nested function, guys. Okay. Now, if I have a function def, I will say that fun1. This is the fun or parent function. I will take it. This is a simple parent function, guys. How to call this one? Now there is a child function. I'm taking it. Here I will give it as a child function. Okay. Now two functions I'm calling. I got the two output over here. See guys, the basic things what you have to know it is the whichever the function is defined along the main program line, they can be called, they are the only functions which can be called from the main program. The function definitions which are not along the main program line, you can't call them. Okay. Now you see this is along the main program line. If you check it out, this is the main program line. Remember this is the main program line. So this is definition is along the main program line. This definition is along the main program line. So you can call it from the main program. No problem with that. But if any function is not along the main program line, you can't call that one. Now let me clear this one off. Here I will take this one and I will put it inside over here. Now this function is a part of parent function. This function is a part of parent function. So now this child function cannot call from the main program because this is definition is not along the main program. So if I try it out, can you see it? You will get it. Name child is not defined. Okay. So this is the problem it is happening. This is. So this is the child of the parent function. The parent is having the full right to execute that. So in order to execute this one, I will be doing it from inside the parent like this. Okay. So how it will goes on now? Now this will be the one. First, it will come down. It will look at the definition over here, the main program, that is the main thread, what is called as. Now from here, it will get into this one. Okay. And then you are going to print it this one. Okay. Then it will come down and look, there is a definition over here. And then from here, it will come down and call the child. From here, it will enter into the child and it will print it. Now, who is authorized to call the child function? Only the parent is officially authorized to call the child function because child is within the parent function. Now you see this, you can do this. Okay, guys. Now, if you want to call the child from the main program, then what you are going to do it? We have to pass the reference of the child function to the main program. How I will do it? Suppose if I am using, I'm not calling it over here. I will use a return and I will use 1,000. What will happen? 1,000 will return where? Here you will be returning it. And I will store it in a variable called as R. Okay, can I print this one? What I will get it if I print R? 1000. No doubt it will get the 1000 over here. Can you see this? You will get the 1000. Okay. Now, in the place of this one, can I get it child over here? What is this child? Is a variable which is holding the reference of the child function. Now that will be returned to this one. Now if I printed this one, let's see this, you will be getting the reference of the child. See, function local child of this one. Okay. Now here, if I want to call the child function, I can use it R of. Okay, guys, clear? Now I'm getting the reference of the child to the main program, and from the main program I'm executing the child function, which is not officially possible. So passing of the reference of one function, the nested function, to the main program and executing the nested function from the main program is called as closure property. Okay, guys, this is the closure property. Clear? Now I want to show you something over here. Let it be there. Now I'm going to create it a function, guys. Let's take it parent function. Here, parent function. This parent, now for example, okay, I will do it something like this. I'm having a message function. Message function, I'm printing the message. Please welcome to, or I will say that, thanks for visiting us. Okay, thanks for visiting us. Now, what is this? If I'm printing this message, how to execute this one? Okay, guys, MSG off. MSG off. Now, when I run this one, clear? Now, this one, who is us? We don't know who is us, right? So maybe it may be a store. I will say that a supermarket. Print greetings from ABC store. Now it makes sense, right? It makes sense. Very clearly, it makes sense. So just imagine, guys, if you are giving it this message, what will happen? It doesn't make any sense at all. Suppose if a customer is there, okay, if a customer is there, now this is your customer, just take it. Now we are a store, right? This is a store, the name is A. Now a customer is coming down to you and you have a software with you. Once the billing is done, taking the mobile number, that software will send a message to the customer. Once the billing is done, that software will send a message to the customer. Okay, clear? Now, because you visited this one, the customer has visited. After this, he went to another store. And he or she went to another store C. Now, while she is shopping at C, maybe she has done the C shopping and she is walking back to her home. Then she got a message that thanks for visiting us. She got the message at that time. Now that time, how she knows that which store it came down that message from? Is there any way? No. There's no way. So what you have to do, you have to make sure of mentioning your store name over there, right? Then only it is possible. But think that this is the software which is used by multiple store people, X, Y, Z, and U, A. How many stores are using? 4 stores are using it. Now, if they change the code in here, the original code, if they want to change it here, print welcome, or what I did it over here, let's do it. This one, greetings from ABC store. This I'm doing the change in the original program, original software. If I do this, I will get the message. Perfectly, it will get the message. But the problem is when a customer will come to this store, he will get the ABC store. This store, it will get the ABC store. This store, it will get the ABC store. Now, it is strongly recommended that don't change the original code, right? Clear? You should not change the original code. So, but this code is, you cannot change this. Now, you are sure that this code, we can't change it. But still, I want to put my message that welcome, this is greetings from ABC store. And I will also put down that on your next visit, take 10% off or 10% discount. I want to give it these 2 messages along with this one. But I can't change this. How I will do it? I will be using a wrapper function. Wrapper function means before this function is running, I want to write it one more function like this. Try to understand. This is my software, right? What is this software consists of? Message like thanks for visiting us. Thanks for shopping with us. Thanks message, it is there. This is a software. Now I wanted to have my store name and saying a message that first it should come down like this. First, greetings from ABC store. First one, it should come down. Following this message, thanks for shopping with us. Thanks for shopping. Now, this is very clearly understood that ABC store, we have shopped it, right? Last, I want to take it on next visit. Avail 10% discount. Like this, I want it. This message is from my main program, main software. The up message and down message, I want to print it at any cost. So what I will do it is, this is the main program which is used by the different companies, different stores. I will make a one more function over here above this. Above this. So when you want to execute this function, first you have to execute this function. In this, I will put on a message like greetings from ABC. So which one will be printed first? Greetings from ABC will be printed. Then it will enter into the main program and then it will be printing thanks. And after that, it will come out, right? When it comes out, where it will come out? Into the outside program. Here, I will say that on avail 10% discount. 10% discount, I will write it. On next visit, avail 10%. So when you call this function, you are having a wrapper function over here. That wrapper function will be executed and then it will enter the original message and then it will print the ending message. Now, this concept is called as decorator. This is your original message. You are running a wrapper function above that one. That is outside that one. Outside the original message, you are running the another function. This is decorating the original function. Now, for example, if you want to give a present to your friend, this is the watch, you want to give it a present. So you will not give it directly, right? You will be putting in a box and you are going to wrap it over here, right? When you wrap it, which one they have to open it first? Which one you will look at? Only the decoration part you are going to look at. First, you have to open the decoration, then only you will see the internal watch. Now, when the decoration is done, the internal watch is changed? No, it will not get changed. No, it will not get. The same way, my original message is not changed. Only before running my original message, I am running what? I'm running a wrapper function, guys. Now this is how it will run it. This is the original message. Now first I'm going to run I have to have a wrapper function, right? This is the wrapper function I'm creating. DEC underscore MSG. Okay. And this will accept one parameter. func. What is this func? Function reference. Which function reference I have to pass it on? The original function reference I have to pass it on. Okay guys, original function reference. Now this is one function. Now this is the reference concept. I said you this is a reference concept. There will be a nested function. DEC underscore inner. Okay. Now this function is, this concept is what? Nested functions concept. This is the function reference concept. We have done it. This one is the nested function concept, guys. Okay. Now here, okay, this is a variable which is holding the function reference. Whose function reference? Original message function reference it will be holding. Okay. Now whichever the variable holding the reference, is it authorized to call? Yes, you can call it. Now I will call this one. I'm not calling the message over here. Now what happens, guys? This one is taking the function reference. Whose function reference? This function reference I'm doing it. Now how I am sending it, I will tell you how I am sending it. Then internally there is one more inner function is there. This inner function is calling func. Func is what? This function, right? Now this is calling the func. Now before the func, I'm putting a message like print greetings from ABC store. Now before calling it, will it print? Yes, it will print. After that it will call, means where it will come down? It will come down to this original function and it will print it. After printing of this one, after completed of execution of the function, where it will return back? It wherever it is called, where it is called, this message function, here it is called. So it will return to this point, guys. And after this, I'm going to put on a print over here. Print avail 10% discount. Can I do it? Now all the connection is done. All the connection is done. Only thing is that I have to execute it. Okay, this is a skeleton part. I'm not creating any decorator as of now. I'm doing manually. Just see this, guys. This is the message. This is a function. Okay, this is a function. Yes. How to call this function? How to call this function? DEC underscore MSG. It is accepting one parameter. What is that parameter? Function reference. What function reference we are going to pass it on? Original function. What is the original function over here? MSJ. Can I put down like this? MSG. What is this? What is this? This is the variable which is holding the address of this one, right? Now this will be, you are calling it, guys. You are calling this function. Okay. Now then you are passing on this value into func. Okay. Now it will come down over here. This is an inner function definition. Will it execute? Will it execute? No, it will not execute. Why? Calling. So you are calling it down over here. I will call it. I will call it, guys. I'm calling it. Just see this. Here I'm going to call it DEC underscore inner. Okay. DEC underscore inner. Now let's see this. What is happening over here? Just observe it, guys. I'm calling this one. Where it is going? Here. Now what is the value I'm passing on? the reference of the original function I'm passing on. This one will be there in the func, and then it will come down over here and it will look the definition of the inner function. After that, it will come down over here and it will call it. Okay. After calling it, it will enter into the inner function. What is there in that first message? Clear? Now, what is the next one? What is func consisting of? Original function reference. From here, it will come down to this one. Yes. And it will execute this one. Okay. Then afterwards, where it will return? Wherever it is called. Where it is called, then what will print in? Now, do I change my original function? I'm getting the thing whatever I wanted. Yes, I'm getting it. Now, this is the base mechanism behind the decorator. Now, I didn't use the decorator over here. Everything I did it manually. Now, you see this? It will run. It should run. Got it? I got it. Now, I'm not done any decoration. So, how the decoration will be working is, this one is a problem. Where it will be the problem is, if this one is accepting some arguments, then that will be a problem. So this whole mechanism, I can do it with a decorator. Now I will show you. I'm taking in another one. This is the fundamental concept without using the decoration. I did that concept. Now using the decoration, we are going to do it. Deco underscore fun. Now I'm going to put down over here. Okay, guys. Now inside this, I'm not going to call this one. I'm not going to call it. And this inner function, we are not going to call it. Okay, inner function, I'm not going to call it. So what I will do it over here is, just see this, guys. Here, this is the inner function. This is the outer function. If I use the return over here, return deco underscore inner. What is this? Deco underscore inner is what? Function reference. Which function reference? Deco underscore inner function is there. This function reference is there. Now where it is returns? Wherever this is called. Where it is called? We didn't call. We didn't call. Okay. So what I will do it is, I will call MSG over here. What I'm calling it? MSG. What will happen over here? It will go and print. Thanks for visiting us only. It will print only. Why means I didn't establish the linkage between these two yet. I didn't establish. So now what I will do it is, at the rate DEC underscore MSG. That's it, guys. Finish. The linkage is done. Now, which one I am calling? Which one I am calling? Original function. I am calling it over here. Now you see this, what will happen? Okay. Now, who is doing this all connection establishment? This one is doing it. This is called as a decorator. This one is called as a decorator. Now, how it will goes on? See, guys, first listen to it. Later on, you can write it. Now here, this one will be called the original message, right? Now the decorator, what it will do is like, it will interrupt this call. It will stop that call. And it will divert this call to this one. Okay, while diverting, whatever the immediate next function is there. What is the next function under the decorator? Message. This reference will be sent along with the call. Along with the call, the message will be sent. Message reference, original function reference will be sent. So this call is diverted and this reference is sent to this one. Got it? Now after this, this is a definition is being seen. Now it will come down and it will return the value. What value it is returning? Inner function reference it is returning. Where it is caught? Where it is caught? Okay, in other words, who is calling the DEC MSG? Who is calling the DEC MSG? Decorator. Decorator is the one which is calling. It is interrupting the original call and it is diverting the call to the DEC MSG, and this one is called by the decorator. So obviously this one will be returned wherever it is called. Where it will return? It will return into decorator. And decorator then internally it will call this one. And then it will be executed. Simple. Okay. This is the internal mechanism. One more time I will explain you. See this. So first is that first you are calling the message over here. You are calling the original function. Okay. Then this call is interrupted by the decorator over here. And this call is diverted into message underscore deco underscore message. While diverted and calling this one, this is a plays an important role. It will take the reference of this and store it in the func. Okay. Clear? Then afterwards it will execute it and it will return a inner function reference. Where it will return? Wherever the outer parent function is called. It will return at this place. Okay. Now then again the decorator, it will be using this reference. It will be calling this function. Okay. And then this will be executed. This is the role of the decorator. Now before I did it without using decorator. Now I am doing with using decorator. Okay. Now the advantage of the decorator is if this one is accepting some message, variable, the original one, then obviously the original call will be passing on some values. That value is stored inside this. Whenever it is calling the inner function, it will be sending it. Now, basically, how you want to remember this one is the outer function will hold the reference of the original function. The inner function will be a replica of the original function signature. Original function signature will be a replica inside the inner function. That is the way it should be. Suppose if I am having over here, now I am passing on some argument over here, num. So obviously I will pass it on some value, num or some name. Okay, let's take it as Arjun is being passed on. Now the Arjun is caught inside this, right? Definitely it is caught inside this. Now I will use it as, I'm doing any mistake? No, right? Where we, okay. Now you see this value will be going into, now if decorator is not there, just see this. B, I will put it on. Now what will be the message, guys? I'm remove the decoration. Thanks for visiting us, Arjun. Right? We got it. Now this one will be there. Now I'm passing it. I'm keeping the decorator over here. DEC underscore MSG. Right? Now see this. See this one. I said it. The original call is called from here. Right? This is interrupted. Right? Now this call is diverted. Okay. Now what will be the func will be having? Original function reference. What is the original function? Message. This reference is gone over here. What happened to Arjun then? Where is Arjun? That Arjun is stored inside the decorator. It will keep inside the decorator. Now after that, when it is coming down over here, and it will pass on the reference of this one to the to the decorator over here, like this, right? Now, as I said it, the inner function should be a replica of the original function signature. Now, what is the original function signature? It is accepting one parameter. That parameter, I will pass it on over here. I will take it any name I will take it. That's it. Now, the decorator, when I am calling the inner function, it will pass on the Arjun name along with this one. This one address is there over here. This will combine with this address and it will call the inner function. Now name will have what? Arjun. Now then here this one is a calling, this is having the reference of original function, but original function is accepting one parameter, right? So where is that a name Arjun now? In the name. I'll put on the name over here. Got it, guys? If I run it, I will get it. Clear? Now this is the concept behind this. So try to do it. Now the multiple ways are there. You can get the multi-level dictionaries, you can get it, and 2 dictionaries for the one message, you can get it, and you can do it anything. Just I gave it some, or because we were having some time, I utilized the time. You can do it whatever you want. We are already in the machine learning, Amitabh. We are doing some data encoding techniques. After officially we are going to get into the NumPy pandas, we'll start the machine learning of the data science. That will be there inside after completion of the files and SQL database. There are 2 concepts left out, files and SQL database. Then we will jump into the NumPy pandas. Okay guys, any questions over here? The func is the actually is the reference of this one, original function. Now the original function is accepting one value, right? So the func is having the reference of original function. If you want to call the original function, definitely you need to pass on the value. That value is stored in the name, so I'm passing it. That's it. You can give it any value over there. If you want to give it some other name, you can give it some other name over there. But you have to pass on this one. This is mandatory. Okay, it's having the function reference, so you have to do it. Yes, Nazia, you can use the single decorator can be used to the multiple functions, or multiple decorators can be used to the single function. And also you can create a method. You can create a method, not only the function, you can use the decorator to a method, and class decorator also you can do it. It's a very vast and very in-depth concept. So here I'm creating a decorator function, guys. So you can create the class also. You can create a class and make a decorator over there. And this function can be used for the multiple functions, and multiple decorators can be used to the single function. Now, if I have one more decorator like this, I can use it DEC ABC. Like this, you can use it, no problem. For this one function, I'm using the multiple decorators. Okay, guys. Now, this is again so you can play with the things. Now, this is one way of implementing. This is a normal function. I'm implementing the original function with a decorator. You can implement a method. Method means inside the class. That also you can implement the decorator, and this decorator can be implemented by using the class. This is a function. Wrapper function it is, but you can use it with the class also. Hope it is clear, guys. Yeah. Just go. రాష్ట్ర అవన్నీ చెప్పింది ఎందుకు మరి కహానియా అంతసేపు డబుల్ టైం ఇని మూడోసారో నాలుగోసారా ఎన్నిసార్లు విన్నావు అది so you can use it the *args, then automatically you give 2 values, 3 values, it will accept and it will do it. Clear, guys? Chalo, then I will stop it. Any questions? Yeah, tomorrow we are going to start with the files, and we are going to do the 3 types of files: text, CSV and PDF. Thank you guys.